Hello and welcome back to Calculus 1 Thursday, right? On this Thursday, we have section 3.10, derivatives of inverse trig functions. So we know trig derivatives already. Derivative of tangent is secant squared, and so on. Now we would like to see what is the derivative of inverse sine, or inverse tangent, or inverse cosecant. So all 6 of those will have their own derivatives. So now we start by writing those formulas out, and the book just gives you the basic case. They say inverse tangent of x or inverse sine of x. I'm actually going to do this in general terms, which means inverse tangent of f of x. So I will be using f of x instead of x, and then because we have the chain rule apply, every answer that the book gives also has to be multiplied by f prime as a chain rule. So let's see these formulas. We start with the derivative of inverse sine of f of x. Now obviously f of x also contains x in that set, so it can be reduced to the formulas given in the book. And that will be f prime of x divided by the square root of 1 minus f of x squared. What happened? So you will take the argument of the sine and then take its derivative and square it for the denominator. The beautiful thing about cosine has the same formula, except there is a minus in front. Actually, all of the 3, cosine, cosecant, and cotangent, will have the identical formulas, except there will be a minus in front. It's very easy to memorize all this stuff. It's just that it's not that useful. So the next one is inverse tangent of any function, and that would be again the derivative divided by 1 plus f squared. So you take function f as is and square it there. And the last one that is establishing this pattern is negative inverse secant of some function, and that one is f prime of x divided by absolute value of f of x times the square root of f of x minus 1.
That absolute value of f of x times square root of f squared, f of x squared minus 1.
That is absolute value of f of x times square root of x, f squared x minus 1. That was the full answer. You can't miss it. Oh, we have time. I mean, I'm here till 10:15. So. Yes.
So where's the square root at? Is it on the f or on the f of x? Or above the x? Where?
I'm completely confused because f of x is one thing.
So like
it's a notation for a function.
If the function squared. Yeah. Not like the exponent.
The square?
Is squared. It's above.
It just says square the function. Whatever the function is, you square the whole function. We good? So I'm going to box these. Yeah, I have to box it because it looks better. Now, what is the inverse cosine? The inverse cosine answer is the same as inverse sine, except has minus in front. So if you want to, write the other ones, then derivative of inverse cosine is going to be given as negative f prime of x divided by the square root of 1 minus f squared of x. So what you're doing is you're just going to copy the same derivatives and put negative in front of those. So you have all of these formulas. You will be able to write inverse cotangent with a minus and inverse cosecant with a minus. Good. And now let's just take a look at a few problems. As I said, it's an extremely short section. So what is the derivative of inverse tangent of x squared minus 3? So the derivative is 1 plus function squared times the derivative of the function on top. And that's it.
So we're not supposed to expand it?
You don't have to worry about the denominators with derivatives, because when you set equal to 0, that denominator will cross multiply into a 0 and just die. So anytime when you are done with the derivative, if you are expanding denominators and playing with denominators, you're wasting time. Because once you find, derivative will do one of the two things. Derivative will either, so far, find a tangent line, or derivative will be set equal to 0 to find min and a max. We'll see that in chapter 4. So if you have a denominator and that's equal to 0, that denominator will cross multiply into a 0 and just die. So there is no need to do anything to a denominator. Let's see the derivative of, say, cosecant inverse of something nice. What? You don't have an idea of what a function? Yeah, I know, but what function should I put? I ran out of functions. Nothing? So just like this? That would be too easy. So what function should I put here? You ran out of functions too. All right. Now let's put just square root of x to make it worse then. What happened? It's called like secant. Yes. I'll give you the trump okay.
Wait, so using the secant equation? Which one are we using?
Yeah, I never gave you the cosecant spelled out. I just told you what it is. So we start with the negative, and then we use the formula on top of the screen. So the derivative in the numerator is 1 over 2 root x, and then denominator has the absolute value of root x, which we don't actually have to write because square root always gives the positive numbers anyway. And then we have a square root of the function squared, so it's just going to be x minus 1. When you square the square root, you get x minus 1. So now to simplify this, we are going to multiply, yes, yes. No, there's no, f of x is equal to just root x. So you just plug where it belongs. So now to simplify everything, we are going to multiply top and bottom by 2 root x. It completely cancels in the numerator, so it just becomes 1. And then in the denominator, root x times root x is just x. So you have 2x, and then square root of x minus 1.
What happens to the absolute value? Just goes away?
As I said, absolute value is not needed because if you look at the square root of x alone always gives positive numbers.
Yeah.
So there's no need for absolute value. Absolute value makes everything positive. Yes? From the formula. The cosecant formula is the same as the secant with the minus in front. So formula for inverse secant doesn't have minus, formula for inverse secant does. And it's the same formulas. Let's take a look at something that book is asking for homework. Oh, they're trying to be sneaky over here. Let's see. One more, and then we'll take a look at related rates. So this is problem 20 in your textbook. It says find the derivative for f of x equal to, actually it's f of t, main variable is t, cosine inverse of t squared. No. Forward. Nice. You start with the chain rule because the entire problem is like x squared. So you start with the chain rule, and then when you have to take the derivative of the inside is when the inverse cosine kicks in. Nice. Wait, what is this? Derivative of cosine sine. Derivative of cosine inverse is you can't because you have square on it. They're asking questions and I'm answering.
Yeah, I don't get it. Squared though? It's like how you
Square the chain rule.
t squared?
How would you do the derivative of x cubed plus 8 squared? It's the same thing. The chain rule is because of the square, yes. And when you're looking for the derivative of the inside, that's when you summon the formula for inverse cosine, which we just learned. Which is the same as sine, just with the negative.
But the derivative of the inside would just be 1.
Yeah. So let's take a look at this, for some reason, confusing problem. We have a chain rule. So f prime of x would be, with the chain rule, we have 2 times cosine inverse of t. And then the formula for inverse cosine is the same as the formula for inverse sine, except it's negative, so it's negative 1 divided by what? There you go. Done. So now you can simplify this a little bit if you want and get negative 2 cosine inverse of t divided by square root of 1 minus t squared and call it a day. Great. All right, so let's end this one. And as I said, everything will be just plug in the formula all the time. That's all it is. Guys, the problem might as well state find the tangent line for, and then you have this function at particular point. That means you are computing the derivative and plugging in values. That's all it is. So this is good for product rule, chain rule, quotient rule, you know, all of it. And that includes tangent line and so on. So anything can be done. All right, we'll restart the stream for related rates.